Hi guys, another lecture part of the head injury subset, talking about mass effect, herniation and GCS in this lecture. So there's something called the Monroe-Kelly doctrine. It's very simple. It just says that the skull is a closed vault and you can only fit a certain amount in there and that amount can't change. So normally that's about 80% brain, 10% blood, 10% cerebrospinal fluid. But what the doctrine says is that that total adding up to 100% can't change. So if something increases, something else has to go. So if you've got bleeding inside your vault, your cranial vault, and the amount of blood is increasing, something else is going to have to go. And the first thing to go is the CSF. It gets squashed down into your spinal column. It gives the brain an extra 10% space to work with. But let's say that lesion gets bigger and bigger. Now the brain's taken up 80%, the blood's taken up 25%, means some of the brain's going to have to go now. And the brain starts getting squashed. And this is called brain herniation. Now the mass of blood from the injury causing this chain of events is called the mass effect. So the effect that the mass of the blood is having. So brain herniation is a fairly simple concept. You can see this blue dotted line is where the midline of the brain should be. And you see that faint white line? That's where the midline of the brain actually is. So we've had a midline shift from the mass effect caused by that bleed. It's starting to herniate the brain, squash it away. Now you have a really big hole at the base of your skull called your foramen magnum, and that's the biggest obvious place for the brain to go if it needs to get squashed out. Its formal name is tonsillar herniation, informally called coning, because the brain starts to form a cone down through that hole. Unfortunately, your brainstem sits right under that hole, so having your brain squashed down on it is normally lethal. Now, one of the ways that we can tell if brain herniation is occurring is with pupil changes. So depending on where the brain is herniating, you'll have different signs. So you may have constricted pupils, particularly for like a posterior herniation at the back of the brain. You may have dilated pupils if both optic nerves are getting squashed. And for something like an uncle or a herniation where the brain is moving to one side or the other, and it just squashes one of the optic nerves, you'll have unequal pupils to reflect that ipsilateral change where just a single nerve is being squashed. Now, some of the other signs you can see in your extremities. So, when we do our GCS, and I'll cover this in the next slide in more detail, you have your motor score, so responds to commands, localizes to pain, withdraws from pain, flexion, extension, no response. This is what flexion and extension look like. So flexion, also called decorticate posturing, is where the arms are flexed into the chest like that. Decerebral, also called extension, posturing is when the arms and the legs are extended and the wrists are typically out like that. These are highly specific signs for traumatic brain injury, and you remember the Glasgow Coma score was initially developed to determine the extent of head injury, of traumatic brain injury. These are very severe signs, and if you see someone start to adopt either of these postures in a traumatic brain injury, you need to prepare for a very rapid deterioration in the patient after that. If you have trouble remembering it, I always remember decorticate, arms to your core, corticate, decorticate. Now GCS, this is what as I said, this is what the GCS was made for, was brain injury. So if you have a GCS of under 9 in a head injured patient, you need to suspect severe brain injury and treat it accordingly. Particularly if you see those flexion and extension movements, which are very specific for TBI.